All right, so here's the end of the assignment, 37. So just 4 questions. Can you find the area of region R? Region R is bounded by x times the square root of x plus 4 and the x-axis. So we need to have the ability to sketch this. So if I want to find that area, if I make it equal to 0, this will give me the intercepts. That's going to help me with the x-axis. So x means one x-intercept is 0. X plus 4, the other x-intercept's at negative 4. So when I graph this, 0, 0, oops, I graphed it the wrong direction. Let me do this again. So let me do it this direction. So 0, 0, 0, 0, and negative 4. Then the question is the curve above or below? It doesn't really kind of matter how high or low it is. Obviously, if whatever number you plug in here, is it going to be a negative answer or a positive answer from 0 to negative 4? So let's say that you plugged in, what's an easy number to plug in? Well, none of it's going to be a rational answer. So let's say you plugged in negative 1. Negative 1 plus 4 is the square root of 3, but negative 1 makes it negative in the square root of 3. So whatever number that's negative, I'm going to plug in. The x in front is going to make the number negative. So however you want to see it, the area curved is right here below. So it's some curve, however you want to see it. This actual curve that connects it matters not. It's this right here where it's top subtract bottom that matters. So how are we going to find the area? It's an integration question from negative 4 to 0. And we're integrating top subtract bottom, which is x. Now I'm going to write this as x plus 4 to the 1/2. So there it is right there. Now, if I'm actually going to find the area of this, I have to integrate this. So from negative 4 to 0, if I'm integrating this, so I'm going to simplify it, that's what's going to give me the area. The derivative of the base, the term, does not match the hook in front. Therefore, this is a u substitution. We're going to let u equal x plus 4. The derivative of u, no, let x equal then, subtract 4, and then take the derivative. So those are the 3 things I need. So I'm going to do a substitution here. X becomes u subtract 4. Make sure it's negative in front. X plus 4 is just u, and dx is du. Now we're going to do some algebra. So we're going to distribute. So make sure that negative in front. So when you go u times u to the half, add the exponents. And it's negative because of the negative in front. A negative times a negative will make the next one actually positive. And now you are ready to integrate. So we're going to add 1 to the exponent. That's 5 over 2, and then the reciprocal. We're going to add 1 to the exponent. That's 3 over 2, and then the reciprocal. And then we're integrating from negative 4 to 0. So I got, oh, you know what I didn't do? Because it's a definite integral, I should have changed the bounds. So negative 4 to 0 is x. So how do I change it in terms of u? Well, plug it in. If you plug 0 in for x, 0 plus 4, now the upper limit is positive 4. If you plug negative 4 in for x, negative 4 plus 4, in terms of u, the bottom limit is now 0. So it goes 4 and 0. So you make sure you remember to change the limits. So now it goes from 0 to 4. So we're going to plug in the upper limit first. That's negative 2/5, 4 to the exponent 5/2, plus 8 over 3. And again, it's 4 to the exponent 3/2, And then I'm going to subtract. Now, when I plug in 0, I'm going from 0 to 4 here. I changed these. When you plug in 0, the answer is 0. So that there is the answer. If I wanted to simplify it, this is what it would look like. The square root of 4 is 2, and 2 to the 5th is 32. The square root of 4 is 2, and 2 cubed is 8. So I have negative 64 over 5. I got 64 over 68 over 3. Common denominators, I get 128 over 15. Silliness. So this is right here is where you need to get to, and that's a great answer. All right, that was 37. 38. I might need some work from 37. Find the volume of that region about the x-axis. So show a setup and then use a calculator to integrate. I like that word, calculator to integrate. So what's the setup going to look like? Let's do that first. So remember the graph, right, that it looks like. So negative 4, and then there's a curve, right? So if I take that, again, where am I revolving around? I'm revolving it around the x-axis. So if you're revolving, it's a circle. This area is hugging or touching the x-axis all the way through. This is a disk. So it's an integration question that's a circle. So we're integrating from negative 4 to 0. It's pi r squared. And then what represents the radius? And again, it's top, subtract bottom. So 0, subtract the curve underneath. So then I write down the curve, which is x in the square root of x plus 4. I'm not going to write it calculus friendly because I'm using my calculator. So it's 0, subtract, that's why it's negative in front, that represents the radius. Top, subtract bottom, gives you that radius right there. That's what that is. All right, use your calculator. So I'm going to go pi. Then I'm going to go menu, calculus, integrate. And I'm integrating from negative 4 to 0. And then I'm going to go parentheses. And then inside the parentheses is negative x and the square root of, make sure I type it right, x plus 4. And then move the cursor. And then square it. Oops, I lost control there. I wrote it twice. Here it is. Boop. So try it again. Square dx. There it is. Okay? So the volume is that, 67.021 or 2. All right, two left, 39 and 40. I'm just looking at the answer key to make sure I'm A-OK. Yep. All right, number 39 and 40, they're just setups. So for number 39, set up an integral for finding the volume of the solid formed by region R by the line y equals 2. So I'm going to sketch it again. Draw the curve. And then put in the line y equals 2 above it. Now, if I'm revolving around it, again it's a circle, but this time the circle is going to be a washer. So if I see the area and y equals 2, I need to know the big radius. That goes from the top all the way to the bottom. So the top is 2, subtract, and the curve. And then we need a little radius. That goes from the top to the beginning of it. Now that's just 2. So the small radius is just 2. Top, subtract bottom, it's just 2. So this is what I'm going to use for my setup. So it's pi. It goes negative 4 to 0. And then the big radius. And you square it. Subtract the little radius and square it. And you have your setup. So this is your big R and your little r. All right, last one, number 40. So set up an integral to find the volume of the solid formed by equilateral triangles, cross sections. And you should have that formula memorized, but there it is, root 3 over 4 s squared, perpendicular to the x-axis. So for this one, again, if I draw a picture of it, so this region that's bounded here, create equilateral triangles to form a volume of a solid. So for the base of that equilateral triangle, again, it's top, subtract bottom, right? So now I don't need there's going to be a negative in front for that base, top, subtract bottom. And then the integral setup goes from negative 4 to 0. The formula is root 3 over 4. That could go in front or beside. And then the base. And you have your answer. And there's the setup to find the volume using equilateral triangles and understanding that that is what we do when it's known cross sections. And the area is root 3 over 4 base squared, and that's what I used. Mr. G Math over and out. I'm proud of you that you've finished your work. Till next time.